This is lesson 86 over arc lengths. We have talked about arcs. I looked back and I'm thinking it was about when we came back after Christmas around lesson 49 that we measured arcs by the measurement of the angles that intercept them. But now we're going to actually look at the length of the arc specifically. And I'm going to have to estimate my center. So what we're saying is if I take a piece of this circle, say from here to here as an arc, where we would measure it like, if this was a 60-degree angle, we would say it's a 60-degree arc, which is true, central angles. But now we literally want to know what is that in centimeters or inches or units. And what we find is we have to go back and talk about circumference of the circle because it ends up being part of the circumference. If we know that circumference of a circle is pi times d, whatever units we're measuring in, if we're measuring in inches or centimeters or whatever, and we can say the whole thing. So if we take if we take a circle and say the radius is 17, we're going to put centimeters on it, okay? And I want to know the whole circumference of the circle. Well, we know that circumference is equal to pi times the diameter. Now, if the radius is 17, then we know the diameter is double that, or 17 plus 17, which is 34. And then if we approximate that, if we multiply and take pi times 34, then we get, and we'll round to hundredths, so let's say that's about 106.81 centimeters. And that's the whole distance around the circle. But we're not going to do the whole circle. We're going to only look at part of it. So we know that from here all the way around, it would be almost 107 centimeters. But we want to know just part of it. So if I set this circle as, and let's just draw another one. And actually we'll call this problem number 1. We'll do the same, and I think I may even still use the same radius. Got a radius of 17 centimeters. But I just want to know the distance. Let's set at let's do a 60-degree angle, because I can estimate that pretty good. And we'll say we have a 60-degree angle. That's this angle right here. And we want to know the distance from here to here. In centimeters. We literally want to know the centimeter measure. So we need the part of the circle that this is. It's not the whole thing. We already know the circumference of the whole thing is 106.81 centimeters. So if I want to find just the measure from here to here, then look at what we're doing. And this is called arc length, and I'll just say, we'll just call it AL. That'll probably be an easy name for it. Is equal to, now I want to know what part of this is of the whole circle. Well, I know the whole circle is 360 degrees, and I know this part of the circle is 60 degrees. And then I know that the whole thing, because we want to take part of that, and the whole thing was pi times d. Now I am going to do some reducing before I make it a decimal, because sometimes they leave them exact. And I can reduce the 60 and the 360 to 1/6. And I will get 34 pi over 6. I'm going to turn it around just a little bit. And then I can reduce again. 2 goes into 34/17 and 2 goes into 6/3. So a lot of times you might see it written 17 pi over 3 centimeters. That's the length. But we're interested in the length of it as compared to the whole thing. This is going to actually just be a 1/6 of that because it's 60 degrees of the 360. So, and I'm going to clear that, just assume that I didn't have it. You can type it several different ways. We could do it here. 17 times pi. Let's see, pi. I can just put 17 pi. And then divided by 3. And that gives me about 17 point, if we do 2 decimal places, the 2 will make the 80 stay the same. It's about a 1/6 of that. We could have typed it here. We could have said 60 times pi times 34. 60 times pi times 34 divided by the 360. And it gives us the same answer. So you can do it as you reduce it. I think it's only going to give you the decimal answer. So you can kind of reduce it as you want to. It just depends on your arithmetic. So what you end up doing for arc length is it's going to be the degree of the angle over 360 degrees, because there's 360 degrees in the circle, and then times the circumference, which is pi times d. There's your formula. Okay, let's try another one. Number 2. Let's do our circle. This time I'm going to give a diameter. I didn't get a very good circle here, but it'll work. And we're going to draw a diameter of, let's say our diameter is 24 inches. And we're going to make our angle 120 degrees. Okay, so we're wanting to know the measurement from here to here. We want to know, we know it's a part of the whole circumference. So arc length is equal to the degree of the angle, 120 degrees over 360 degrees times pi times the diameter, which was 24 inches. Now, let's see if we can do some reducing. I like to reduce. It just makes it a little bit easier. 120 and 360. If you divide 120 into both of them, you get 1/3. Then you can cancel the 3 and the 24 if you choose to do that. And so you end up with 8 pi. Now, you could have typed it in your calculator just like this. Just saves me a little bit of time, and the answer is 8 pi inches. And I want the decimal. So I've got 8 times, you don't have to put the times in there. I'm just doing that because I know in some calculators, depending on what you're using, and we get about 25.13 inches. Now remember, if you don't have a calculator that has a pi key, the best for pi is to approximate it is 3.14159. It will match up with the multiple choice much better. Okay, let's do one more, because you may see something in these you've not seen before. You may see an angle that's more than 180 degrees. Let's do our angle at, I want to see how they're drawing these. They're actually putting little arrows in here and showing what your angles are. So we're going to do this one, and we're going to draw it from here, see what's going to happen. Now, you could look at it this way, but they want the bigger angle, so they want the bigger arc. Remember, we talked about major arc and minor arc, and so we actually want to know the length of this major arc here. And we're going to let that angle, it's more than 180, let's let it be 200 degrees. Okay. And I'm going to let the radius be 9, what have we not used? Let's do millimeters. So arc length, the measure from here to here, this major arc here, is 200 degrees over 360 degrees times pi times the diameter of the circle, which would be 18. Now, if you don't want to do the, here you go. If you don't want to do the canceling, I like to do it, but if you don't want to, you can actually just type it like it's given. I'm just going to type the top. I'm going to put 1 under these, so I'm just going to do this times that divided by 360, and it'll work. So I've got 200, let's see if I can get on camera, times pi times 18. That's my top. Now the bottom's just 360 times 1, so I'm just going to divide by 360. And I get 31 point, and now the 5's going to make that round to 42. Now, I don't know on yours what it's going to round to. Let's see. It looks like it's going to round to 1 decimal place. So in this case, if you did 1, the 1 would make the 4 stay the same. So that's going to be approximately 31.4, and our units were millimeters. So this is just a piece of the circle around it. And then the last lesson this week will be 86, that will be we'll do part of the area. Instead of the area of the whole circle, we'll do area of a little piece of the pie, just like a slice of pie or slice of pizza, and we will look at the area of it, and that will actually be called a sector. It's just a piece segment of the circle.